Welcome back, everyone, to part 3 of our series on units and measurements. Today, we're going to dive into a really powerful tool for your NEET prep, dimensional analysis. I'm going to show you how this method can actually save you from memorizing dozens of formulas by helping you build them from scratch. I know it can feel overwhelming. The pressure of exams, all those formulas, it feels like you have to memorize everything, right? But what if I told you there's a smarter way, a more logical way to handle formulas that's all about understanding, not just memory? So, here's our game plan for today. First, we'll talk about why this is so much better than just memorizing. Then, I'll walk you through a simple step-by-step method. We'll actually build a formula together right from the beginning. And finally, we'll cover the really important rules and limitations, so you know exactly how to use this to your advantage on the NEET exam. So why is this method such a big deal? Well, it takes you from just cramming facts to actually understanding the relationships between different physical quantities. It's all about seeing the logic behind the formulas. And trust me, that is a much more powerful way to learn. This whole thing is built on one simple, beautiful idea that we talked about in part 2, the principle of homogeneity. All it says is that you can only add, subtract, or equate things that have the same dimensions. You know you can't add meters to kilograms, right? In the same way, an equation can't say that force equals velocity. This one single rule is the key to everything we're about to do. Okay, so how do we actually do this? Let's break it down into a simple process that you can follow every single time. Think of this as your guide to building any formula you need. Think of this as your recipe. Step 1 is super simple. Just figure out what you're trying to find and what other things it depends on. In step 2, we just set up a general equation with some unknown powers. Don't worry, we're going to find them. Step 3 is where we write down the dimensions for every single piece. Then the magic happens in step 4. We use our principle of homogeneity to make sure both sides of the equation match up. That gives us a few simple equations to solve in step 5. And finally, in step 6, we just plug our answers back in to reveal the final formula. Let's see how it works with a real example. Okay, let's put this method to the test with a classic physics example that you'll definitely see again, the simple pendulum. And hey, don't worry if you've forgotten the formula. That's the whole point. We're about to build it from scratch, just using logic. All right, here's our problem. This is step 1 of our method, identify. The question tells us everything we need to know. We're looking for the time period, t, and we know it depends on 3 things: the mass, the length, and gravity. That's it. That's all the info we need to get started. This brings us right to step 3, which is writing down the dimensional formulas for everything we're working with. So for time period, the dimension is just t. For mass, it's m. For length, it's L. And for acceleration due to gravity, that's length per time squared, so LT to the minus 2. Having these ready is key. Okay, now let's just rewind for a second to step 2. Assume. We set up a general relationship. We just say that the time period, t, is proportional to the length raised to some unknown power x, mass to a power y, and gravity to a power z. That little k is just a constant with no dimensions, so we don't have to worry about it for now. Our entire mission here is just to figure out what x, y, and z are. And here we are at step 4, the most important part. We equate the powers. Just look at the row for mass. On the left side of our equation, the power of m is 0. On the right side, it's y. So for the dimensions to match, y has to be 0. See? We do the exact same thing for length and time, and that gives us these 3 simple equations to solve. And just like that, we solve them, and we have our powers. This is step 5. But wait, look at this. The power for mass, y, turned out to be 0. That tells us something really amazing that we just proved for ourselves. The time period of a pendulum doesn't depend on its mass at all. A heavy bob and a light bob will swing at the exact same rate. How cool is that? And now for the final step, step 6. Substitute. We take the powers we found and put them back into our equation. Length to the power of 1/2 is just the square root of length. Mass to the power of 0 is just 1, so it basically disappears. And gravity to the power of -1/2 means it goes in the denominator under that square root. And there you have it. We literally built the formula from scratch. Just take a second to let that sink in. This isn't some kind of magic trick. It's a straightforward, logical process. Once you practice it a few times, you'll see you can apply this logic to so many different problems. You really can do this. Okay, so this is a really, really powerful tool. But like any tool, it's important to know its rules and its limits. Knowing when you can't use this method is just as important as knowing when you can.
So let's do a quick review of the key rules. First, remember, everything is built on that principle of homogeneity. The dimensions have to be balanced on both sides. Second, we can totally ignore any pure numbers like 2 or pi, since they don't have dimensions. And most importantly, you have to be told what variables the quantity depends on to get started.
Now, you're gonna wanna pay close attention here, because these limitations are a favorite for tricky questions on the NEET exam. Remember that k constant we had? Well, dimensional analysis can't tell us that its value is actually 2 pi. It also can't handle any formulas that have plus or minus signs, or things like sine and cosine. If you see those in a formula, you know right away that this method won't work for it. All right, let's bring this all together. How does this skill actually give you an advantage in the NEET exam? Because this isn't just theory, this is a practical tool you can use to succeed. This is the real superpower it gives you. Imagine you're in the exam. You're stuck on a question. You kind of remember a formula, but was it a square or a square root? Instead of panicking or guessing, you can take 30 seconds, check the dimensions, and know for sure. It lets you eliminate the wrong answers and solve problems with total confidence. So, to make sure you get the most out of this, let's look at the common traps to avoid. First, always remember those limitations we just talked about. Be super careful with your algebra when you're solving for the powers. It's easy to make a small mistake there. And finally, you've got to practice the basic dimensional formulas until they become second nature. Practice is what's going to make this fast and easy for you. So, I'll leave you with a little challenge. You now have the complete 6-step method. How would you approach this problem? Give it a try. You have all the tools you need now. Keep practicing, and you'll start to see that physics is really just a series of logical puzzles. Puzzles you now know how to solve.